Hello, algebra students, Mr. Lawrence here, and I got to tell you, some of you have been working so hard at trying to solve these literal equations. I'm very proud of the effort you're doing. You're learning to see these variables as numbers, unknown numbers, but numbers nonetheless. All right, here are 4 problems. I'd like you to try all 4 of them on your own. Pardon me. And then I will go ahead and show you my solutions. So please try all 4 problems. Hold on, there's a special delivery at the door. Would you like to say hi, James?
Hi.
All right, James is here and he brought me a special delivery and I'm not sure what it says. Can you translate it for me?
It's for Mrs. Cosman and Mrs. Maines and my friends.
Excellent. He made some houses for his teachers and some friends.
I just made
All
one.
right. Very nice.
And it's going to be all together.
Okay, very good. Now I got to get back to the video, James, so go get your shoes on and we'll go to Target soon.
Okay.
Close my door. Close my door. Close my door.
I forgot.
Thank you. All right, sorry about that, ladies and gentlemen. Go ahead and pause the video. Solve for the indicated variable in each problem. If you're still watching at this point, I'm going to solve for y. Now, one thing I like to do, especially if people are having a hard time, is I like to circle the variable I'm solving for. And I'm going to think about this as a 6x. Remember Dylan the other day in class called this a 6x, right? Not a 6, not an x, a 6x, okay? And I'm going to ask myself the questions that you saw in the video or in class. You know, what numbers are attached to y? Well, there's a 3 attached by multiplication, right? And there's a 6x attached by addition because the 6x is positive. Saddam tells me to get rid of the 6x first, so I'm going to subtract 6x from both sides. All right, when I do that, I'm going to get 3y is going to equal to negative 6x plus 17. Some of you want to write the 17 and then minus 6x. That's perfectly fine. I just know that, like Mackenzie Mayo was quoting in class on Tuesday, no, that was Monday, sorry, that Mr. Lawrence says to write this x term first because it's something we're going to do later. Okay, now the 3 is attached to y by multiplication, so I'm going to divide by 3, and I've got to do it in all 3 places. When I do that, the 3's will cancel. I'll get y equals negative 2x, and then it's okay to go mixed number here, and so I will. I'll get 6 1/3. Hey, buddy, I need you to go out to the other room, okay? Go out to the other room for me. I'll be done soon. Please don't pout. Okay, so there is the equation solved for y. Now, it's important to note that this equation here, 6x plus 3y equals 17, is the same equation as this one. They are the same linear equation, just written in different forms. All right, let's go on to number 2. I'm going to solve for j. I'm going to circle that. There we go. What numbers are attached to j? Well, I've got a k attached by multiplication. Oh, I'm sorry, an h attached by multiplication. And I've got an fg attached by addition again. Remember that negative belongs to the h. So I'm going to subtract the fg. Subtract the fg. Now, the right-hand side is easy because they are not like terms. Okay, the left-hand side is easy because the FG's cancel. There's really nothing difficult about these problems. They sure look strange. And some of you go, wait, there's too many letters. I don't know what to do. But really, you just follow the same procedure as you do when there's numbers there. Okay, now the negative h is attached to j by multiplication, so I'm going to divide by negative h. It doesn't look like an h, does it? No, hopefully it looks better. So I'm going to divide by negative h. And I'll divide by negative h. All right, I'm going to get j is going to equal the negative of kn over h plus fg over h. The 2 negatives cancel, right? 2 negatives cancel. Get me this. And then we have the negative. Now, it is unusual to keep a negative in the denominator like that. Usually we put it in front of the fraction or we put it in the numerator. So you could have this and it would be the same as this. It's also the same as this. All 3 of them are mathematically equivalent. This one is just really unusual. We don't usually see a negative down there. We usually bring the negative out front of the fraction or put it in the numerator. All right, let's go on to problem 3. Oh dear. Okay, we're solving for m. And so there's an m. And what is attached to the m? Well, a b squared, not an m squared. No, the m is not being squared, only the v is. So how is the v squared attached to m? By an exponent? No, it's being multiplied. So I'm going to have to divide by what? By v squared. If I do it there, I'm going to have to do it there, and so I'm going to divide by v squared. V squared. So m is going to equal p over v squared minus q over v squared. And there you go. That's it. Pretty easy. All right, 4. It looks like the same equation, except this time I'm solving for v. Well, I'm going to get rid of, I'm going to listen to sad me, and I'm going to get rid of multiplication before I get rid of exponents. The m is attached to v by multiplication, right? So I'm going to divide by m. I'm going to divide by m. I'm going to divide by m. So I'm going to have p over m minus q over m. And that will equal v squared. All right, so now I'm going to take the square root of both sides, and that's going to get a little bit strange. We don't really know how to work with this kind of square root yet. So for right now, where we're at in our learning, we know the square root of v squared is v, and then you can tell me this, p over m minus q over m. Okay, later on we'll learn how to deal with those, but for right now, that's where we're at. Okay, so pay attention to your order of operations, and we're going in the inverse. That's why I like to use Saddam, the opposite direction, that is. Saddam or sad me. I suppose if there were parentheses, I would listen to sad mep. Right? Okay. All right, that's it for the video. We're getting lots of practice with this in class. I'm proud of you guys and girls. Keep it up. Mr. Laurence signing off. Have a good night, everybody.